फिर अपने वीडियो
ना नहीं अभी तक प्रोफेसर। मैं तो भाग के आ गए। अरे आओ ना रे। कितना टाइम हो गया।
So, good evening, all of you.
Good evening, sir.
गुड इवनिंग
Good
सर।
evening. Good evening. Good evening. Good evening. So, in this lecture, we are going to start with new topic of mathematical physics, and that is vector analysis. And you will see after vector analysis, I will start with electricity and magnetism. So, there is reason behind it why I am first discussing vector analysis and then electricity and magnetism. So, because you know that electric field and magnetic field E and B, they are vector quantities. So they have magnitude and directions. And you will see there are different types of symmetry that we encounter when we study electricity and magnetism. Like you have Cartesian symmetry, spherical symmetry, or cylindrical symmetry. So you must know how to deal these vectors in different coordinate system. Sometimes you will see we have to transform vector from one system to other system also. Then you will encounter like electric field is, let's say E is minus of gradient V. So you must know what is gradient V, how to find it. You will see divergence of E is rho by epsilon naught, Gauss law. So you must know what is divergence. Similarly, curl of E is 0 for electrostatic field. So you will encounter gradient, divergence, curl. You will also see how to find line integral, surface integral, volume integral. And all these things we will discuss in vector analysis. So that's why I am first discussing with you vector analysis chapter, and then we will move on to the electricity and magnetism. Is it clear?
Yes, sir.
Okay.
Yes.
So this is the first lecture of vector analysis, and this will be the introductory lecture. First lecture will be always introductory lecture because we have to see basic concepts, and then from second lecture we will move on to the other parts. So it's a introductory lecture for vector analysis. So we will talk about vector analysis. So first thing is, for any chapter, first thing is you should remember the syllabus. Once you remember the syllabus, then you know what topics you have to study. Is it clear? So always remember the syllabus for different topics. So that's why I will first discuss the syllabus part. What is the syllabus for vector analysis? So first, I will discuss the coordinate system. We will talk about coordinate systems. So we will talk about Cartesian coordinate system. Cartesian. Please note down the syllabus. Cartesian coordinate system. How to deal vector in Cartesian symmetry, X, Y, Z symmetry. We will discuss it. Then we have a spherical polar coordinate system. A spherical polar coordinate system. And third, we have cylindrical coordinate system. Cylindrical coordinate system. You will see in this coordinate systems, coordinates are x, y, z. Here we will talk about r, theta, phi. And here we will introduce r, phi, z. Is it clear?
Yes, sir.
Now, we will also talk about transformation of vector from one system to other system. Transformation of a vector from one system to other. From one system to other. So you will see we can transform a vector from Cartesian to cylindrical, or you can transform a vector from cylindrical to Cartesian. That is both way. In the same way, we will see how to transform a vector from Cartesian to spherical, and then spherical to Cartesian also. So that will be the part of the coordinate system. Clear? Then we will introduce about gradient, how to calculate mathematically, and what does gradient, divergence and curl represent. So we will talk about gradient, divergence and curl. And we call it as a first derivative. These are the first derivative. We will also talk about some second derivative. Some second derivatives. Some second derivatives. We will also see product rules for gradient, divergence and curl. And you have to remember these rules. Product rules for gradient, divergence and curl. Is it clear?
Yes, sir.
Okay. Then we will see, we will define what is line integral, surface integral, surface integral and volume integral. And volume integral. You have to see how to calculate these integrals in different coordinate system. When symmetry is spherical, you will see that in spherical symmetry, you can simplify your calculation. When symmetry is Cartesian, you have to use Cartesian. When symmetry is cylindrical, you have to use cylindrical coordinate system. So we will discuss all those things. And then we will talk about fundamental theorem of curl. Fundamental theorem of curl. Let's see. First, we will talk about fundamental theorem of gradient, then divergence, then curl. So, fundamental theorem of gradient. Then we will see fundamental theorem of divergence. So, we call it as a Gauss divergence theorem. Gauss divergence theorem. Gauss divergence theorem. And we have also fundamental theorem of curl. So we call it as a Stokes theorem. And there is another theorem that we'll discuss, that is nothing but a Stokes theorem applied in 2 dimensions. So because separately questions are asked, so we will talk about Green's theorem. Okay? So in vector analysis, we are going to discuss all these concepts and topics. Yes or no? Please note
Yes,
down.
sir.
Note it down.
Yes, sir.
Chalo. Can I take next slide?
Yes, sir.
Okay.
Okay, sir.
So you know about vectors. So I will first give you the definition. As I told you, it's an introductory lecture. So we will talk about some basic results. You already know these results, but I am revising it because it's a basic part. So we will cover all those things. Okay. So what is a vector? You all know that vector has magnitude and direction, and they follow the vector law of addition. So what are the vector quantities? So vector quantity have magnitude, direction, and they follow. We will discuss vector law of addition. They follow vector law of addition. Law of addition. You know examples like you have electric field, and we represent it by this symbol E. You have magnetic field. Magnetic field, whenever it has magnitude, direction, they obey vector law of addition. You can call it as a vector. We have a force, acceleration, velocity, and so on. Acceleration, velocity, all those things are vector quantities. Is it clear?
Yes, sir.
Now, in general, it is represented by this symbol, where A is a vector quantity. So, and this vector A can be represented by this arrow. Let's represent a vector by this arrow. This is the tail of the vector, and this is the head of the vector. And you will see this is vector A. Now, length of the vector is magnitude of A. So, length of vector is magnitude, and magnitude is given by mod A. So, magnitude of vector represents the length of the vector. And this, we represent a unit vector along this direction. So that unit vector, let's represent A cap. A cap is unit vector along the direction of vector A. And this unit vector is A cap, and this is given by vector A by mod A. I know you know these concepts, but let me just introduce the basic points. Yes or no?
Yes,
Yes,
sir.
sir.
So
Yes,
we will
sir.
start from basic, and then we will go to the advanced part. So this is the magnitude of vector A. Now what is minus of A is given by minus A vector. And how to represent minus A? Everything will remain same, just direction will change. Only direction will change. So this is minus of A vector. Magnitude is same value. Length will be same, only direction will be changed. Now this unit vector is in the direction of minus A cap. Is it clear? So I have introduced about the vector, how to represent it. A may be anything, electric field, magnetic field, any vector quantity. I am giving you the general term, that is vector A. ठीक है?
Yes, sir.
So please note down. Now you know that there are 4 basic operations that you can perform on a vector. What are those? Can you tell? What are the 4 basic operations?
Addition,
One is
subtraction.
addition, and there are 3 types of multiplication. One we call it as, you can multiply a vector by a scalar. You can multiply a vector by a scalar. Then another multiplication is dot product of 2 vectors. And another multiplication is cross product of 2 vectors. So you must know what are the 4 basic operations that we can perform on any vectors. So can I take next slide?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So let's see the basic operation, vector operations. So as I have told you, we will talk about 4 basic operation. One is addition, and there will be 3 types of multiplication. So first is vector addition. Vector addition. So let's say you have 2 vectors A and B, and I have told you that they follow the vector law of addition. So there is a one vector A here. This is vector A. And we have another vector. Let's see. Let's take it as like this. Let's take, this is a vector A. And there is another vector B. And we want A plus B. Let resultant of these 2 vector is A plus B. So what is the vector addition? How you will represent that vector? So A plus B. So we will first place the vector A. This will be vector A. This is tail of A, and this is head of A. And then first you have to place A, then place tail of B on the head of A. So this will be vector B. And if you connect this will be the vector R. This is the resultant A plus B. Now this will be the magnitude. If you see this arrow length R is the magnitude of A plus B, and this will be the direction of A plus B. Is it clear? A plus B. So first you should place A on the head of A, place the tail of B, and then connect tail of A with head of B. So this will be the resultant vector. This is the vector addition of A plus B. We can have B plus A also, and you will see the same R you will get, B plus A. Now this is B vector. This is tail and this is head. This is A vector. In same way, so resultant R will be this, B plus A. So you will see vector addition is commutative. Vector addition is commutative. Addition is commutative. So commutative means A plus B is same as B plus A. addition is also associative. You will see addition is also associative. Associative. So in this, if you add, let's say, if you are adding first A plus B, first add A plus B and then add with C. And this will be same as if you add B and C first, then add with A. So it also follows the associative law. Is it clear? So addition is commutative and addition is also follows the associative law. Clear?
Yes, sir.
Yes, sir.
Now, why I'm not defining subtraction? Because you can subtract two vector also. So subtraction is nothing but a addition, because if you have to define A minus B, and this is nothing but A plus, just change the direction of B. So let's say this resultant is I am taking to be R dash. A minus B is nothing but a addition with direction of B changed. So let's say you have first A vector. Same A vector I am placing here. Now you have with plus B vector with direction of B change. So let's change the direction of B. So this is minus of B. So you are adding A plus of minus B. So this will be the resultant R dash. Is it clear?
Yes, sir.
So that is the vector law of addition. Okay? So first vector operation is addition. They follow the vector law of addition. We can find magnitude and direction. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, please note down.
Yes, sir.
Chalo. Now next one is, second one is multiplication by a scalar. Second is, you can multiply a vector, multiplication by a scalar. So let alpha be some non-zero scalar. Non-zero scalar. And A is some vector and A is some vector. Then we can define alpha A. We can define alpha A. So if A is a vector, so what will happen? You will see if alpha is positive, then only magnitude will change, direction will remain same. But when alpha is negative, depending on alpha, magnitude and direction both will change. So alpha may, when alpha greater than 0, direction remains same. Remains same. Direction will not change. But when alpha is less than 0, then direction will also change. Magnitude, of course, depending on alpha, magnitude will change. If alpha is not 1, magnitude will change. So direction will also change. I have already told you what is minus of A. What is minus of A? You are multiplying here alpha is -1. So in this case, magnitude will remain same, only direction will change. Yes or no? Same magnitude and direction will change. If you have, let's say 1/2 vector A, alpha is half. So what will happen? Magnitude will be simply half and direction will be same. Yes or no? If you have, let's say 2A. So in this case, what will happen? Magnitude will be double. So this will represent 2A vector. Okay? So it means what? You can multiply a vector by a scalar. And you know the meaning of multiplication of a vector by a scalar. Is it correct?
Yes, sir.
Now next is we have to define dot product of two vectors. That is again multiplication, but that multiplication is defined as dot product. But let me first define what is the angle between two vectors. Do you know what is angle between two vectors? How we will define angle between two vectors? Angle between two vectors. Now consider this is vector B and this is vector A. Let's say this angle is theta and this angle is beta. So what will be the angle between A and B? How you will identify angle? Because there are two angles between A and B. One you can see theta also, another angle is beta also. So what will be angle between A and B?
Smaller angle, tail to tail position.
Yes. So definition is you have to connect two vector tail to tail. What is tail to tail means? This is the tail of vector B and this is tail of vector A. So when smaller of the two angle between A and B, when they are connected tail to tail, must remember this definition. What is the angle between two vector? The angle between two vectors is the smaller of the two angles between them, when they are connected, tail to tail. Must remember this, they are connected tail to tail. So in this case, theta is the angle because this is the smaller angle. Yes or no? So this angle always lies between 0 to 180 degree. Is it clear? Yes or no?
Yes, sir.
For example, if I ask you if this is a vector A and this is another vector B, and let's say this angle is 110 degree. So can you identify what will be angle between A and B? Yes,
70
anyone?
Sir,
Yes,
70
so
degree.
yes, what you have to do, you have to place them tail to tail. So this is vector A, this will be its tail. Now place, this is the tail of B, place this vector. This is vector B. So if you extend this, what will be this angle? This angle is 70 degree. So angle between two vector is 70 degree, not 110. Yes or no? So first you should see how you will identify the angle. So you have to place the vector tail to tail. Then you have to see the smaller of the two angle. That will be the angle between two vector. I think this point is clear. Is it clear?
Yes, sir.
Now in this case, this angle is 60 degree. So now here it is directly connected tail to tail. In this situation, you will see theta is 60 degree. But here theta is 70 degree. So it's a small point, but you should remember how we will identify the angle between two vectors. Clear?
Yes, sir.
So please note down. Then I will introduce the dot product of two vector because we require the angle between two vector. That's why I have initially introduced it. And now I will talk about the dot product. Okay? Please note down. Can I take next slide?
Yes.
Okay. Now we will see the third operation. We are discussing vector operation. Vector operations. We have already discussed addition, then multiplication with a scalar. Now this multiplication is called as dot product of two vector. Dot product of two vectors. Dot product of two vectors. Dot product of two vectors. So let's see. This is vector A and they are connected tail to tail. This is vector B and this is the angle between two vectors. Okay? Theta is the angle between two vectors. So we can define dot product is like A dot B. A dot B. So let's see if we say, see projection of, let's draw right angle triangle here. By this point, draw perpendicular on this. So you will get a triangle and in triangle, what will be this perpendicular length? Can you find? Sin theta, cos theta term. So this projection is what? Mod B cos theta. Mod B or simply B without vector B that represents the magnitude. And what will be this projection? This is mod B sin theta. Yes or no?
Yes,
So
sir.
must remember the triangle rule that if you know the angle between two vectors that is theta, so projection along another vector is cos theta and projection perpendicular to that vector is mod B sin theta. So here geometrically mod A dot B is, so you have to see mod A and then you are multiplying mod B cos theta. Okay? So this is mod A and then projection of B along A. And it's a scalar value. Now, and this can be also written as what? Mod B, or you can take projection of A along. You can also take, if you draw perpendicular from A to B. So along this direction projection will, this is mod B cos theta. And in perpendicular direction projection will be mod A sin theta. So both are same thing. And this will be a scalar value. Yes or no? It's a scalar value. And you will see A dot B is B dot A. Again, it's a commutative. Dot product is a commutative. it is commutative. This is also distributive. What is distributive? So if you have A dot B plus C, this can be written as A dot B plus A dot C. So this property is distributive property. Distributive property. Clear? Now, if vector A is perpendicular to vector B, then you will see A dot B will be 0. If two vectors are perpendicular, their dot product will be 0. If A is parallel to B, then A, because angle will be 0, so A dot B is simply mod A into mod B cos 0, or this will be simply A into B. A is the magnitude of vector A and B is the magnitude of vector B. Is it clear?
Yes, sir.
Now, let's see, we can define, sometime you have to find the resultant of what will be law of cosine here. Law of cosine. So let C vector is given as A minus B. Let's see, C vector is A minus B. So this is vector B. This is vector A. This angle is theta. So how we will represent C vector? C is A minus B. This will be C A minus B. Yes or no? So angle between two vector is given, because now B, this will be A is equal to what? C plus B is A. Is it clear? So C direction will be this. Yes or no?
Yes, sir.
Now if you take C dot C, what you will get? This is A minus B dot A minus B. So this is given. A dot A is A square, B dot B is B square. You will get 2AB. This is minus 2AB cos theta. And C dot C will be, this will be C square. Okay? So in this case, you can directly find the magnitude of C, that is A minus B. This is given as A square plus B square minus 2AB cos theta. Clear?
Yes, sir.
So this is the third vector operation. Please note down. Can I take fourth one?
Yes, sir.
Fourth one is cross product of two vector. Cross product of two vectors. Fourth one is cross product of two vectors. Now we will define cross product of two vectors. So again, let us consider this is vector B and this is vector A, and angle between these two vectors is theta. So what will be A cross B? Now you know that if you take projection along this direction, what will be that projection?
A sin theta.
Mod A sin theta. So A cross B is given by, let's say, mod B into mod A sin theta. And there is a direction associated with A cross B, and that direction is n cap. N cap is the direction of A cross B. This is the direction of A cross B. Now, what will be direction of the cross product of two vectors? So this is very important, how to find the direction of cross product of two vectors. So for that, we have to use right hand rule. Right hand rule. In short, RHR. Please remember the right hand rule. You will see throughout electricity and magnetism, I will use only right hand rule, no left hand rule, because at 12th standard, you also study left hand rule also. But now we will see only right hand rule. So you have to use your only right hand. And you will see in different situation around 7 to 8 times I will use right hand rule in different form. So please, on one separate sheet, you just write down right hand rule and note it down, number 1, number 2, number 3. So this is the first time I am introducing, because you may get confused when you apply 8 times of right hand rule in different situation. So if you note on same one page, then you can easily revise in which situation you have to apply this particular right hand rule. Is it clear?
Yes, sir.
So
Yes, sir.
first time I am introducing for cross product. You will see in vector itself. Second time I will apply for area vector. What will be the direction of area element on an open surface? So 2 times I will discuss right hand rule in vector analysis, and others we will discuss in electricity and magnetism. Clear? Is it clear?
Yes, sir.
Yes, sir.
So now you have to use only right hand rule. So what is right hand rule? Use your right hand and move your fingers from A to B. If you have to find right hand, if you have to find A cross B. So use your right hand, move your fingers from A to B via a smaller angle. Use your right hand. Can I write it? Use your right hand and move or curl your finger and move your fingers via smaller angle. Then thumb will give direction of cross product of two vectors. Magnitude is mod A, mod B sine theta. That is same as mod A, mod B. So magnitude, you know, where theta is the angle between two vector. You know angle between two vector when they are placed tail to tail. So what will be direction of A cross B? Just see, pointing inward. Direction is n cap will be inward into the board. And when you have to see B cross A, use your right hand, move your fingers from B to A by a smaller angle. So in this case, n cap will be outward. Yes or no?
Yes, sir.
So you know magnitude and direction of cross product of two vectors. Now, cross product is also distributive. This follows the distributive law. Means if you have A cross B plus C, sorry, plus A cross C, but cross product is not commutative. Cross product is not commutative. A cross B is not equal to B cross A. Why? Because you know that A cross B will be minus of B cross A. Yes or no? ठीक है?
Yes, sir.
Now, if A is perpendicular to B, so what will be theta? Theta will be 90 degree. So A cross B will be given by AB n cap. If A is parallel to B, theta is 0, then A cross B is 0. ठीक है?
Yes, sir.
Is it clear?
Yes, sir.
Now, what does A cross B represents geometrically? What does this A cross B represent? So geometrically, mod A cross B is the area of parallelogram formed by A and B. So what will be the area of the parallelogram? Let's say this vector is A and this vector is B. So let's draw a parallelogram. So draw a parallel line to this, and then this will be B parallel to this, and this is A parallel to this. So mod A cross B geometrically, mod A cross B represents area of the parallelogram formed by A and B. Yes or no? So mod A cross B represents area of the parallelogram formed by A cross B. Is it clear? Yes or no?
Yes, sir.
So must remember that mod A cross B is the area of parallelogram formed by A and B. So these are the four vector operation. This just represents area of parallelogram formed by A and B. Formed by A and B. Clear? ठीक है?
Yes, sir.
So we have just introduced about vectors and what are the four basic operations. Just give me 1 minute. So now we will introduce the coordinate system. Now we will talk about coordinate system. Can I take next slide?
Sir, 1
Yes,
minute.
sir.
Okay, please note down.
Done, sir.
Okay. So now let's focus. Now this first 2-3 lectures are very important. If you understand the symmetry, you can easily apply concepts when we deal vector E, especially E and B in spherical symmetry, cylindrical symmetry, and Cartesian symmetry. So must focus on coordinate system. This is very important.
So,
Yes.
so how to find the unit vector n cap of a vector triple product? For example, if we have three vectors, vector A, B,
Let
and
me.
C.
I have. Yes, I will discuss. Let me introduce the. Till now, I talked about only cross product of two vectors. So when we talk about general coordinate system, then we talk about x, y, z. No? In that we will discuss the triple product also. So let me complete.
Okay, sir.
Coordinate system. So first one is Cartesian coordinate system. So Cartesian coordinates are x, y, z. So till now, I have just represented any vector by this symbol. Vector A, you know about its magnitude and you know it's a unit vector. So this general vector is represented in space. But if you want to specify that vector, you need coordinate system. And we have three coordinate system: Cartesian, spherical, and cylindrical. So let me first introduce the Cartesian coordinate system. Then how to represent vector A. So vector A is given by AX x cap, AY y cap, AZ z cap. This is vector A in Cartesian coordinate system. So x cap, y cap, z cap are the unit vector and component along these direction is AX, AY and AZ. So you know that in a Cartesian coordinate system, we have three mutually perpendicular axes. X, Y and Z. So there are three mutually perpendicular axes, X, Y, Z. And what is the unit vector? Unit vector. Its magnitude is 1. Its magnitude is 1. And direction of unit vector, direction of unit vector is always in the direction of their increasing coordinates. Increasing coordinates. Increasing coordinates means x, y, z coordinate. So what if you know the increasing direction of x, so that will be the direction of x cap. So this is the origin, and in this direction x is increasing. So what will be positive direction of x cap? I am specifying x cap direction. So this will be the x cap direction. By definition, unit vectors direction is always in the increasing direction of their coordinates. So this is the direction of y is increasing. So this is the direction of y cap. Y is increasing. So this is the direction of z cap. Yes or no?
Yes, sir.
Then what will be negative x cap? Opposite to this negative x. This is negative y. This is negative z. Clear?
Yes, sir.
Now, if you want to represent vector A, so along in the x direction component is AX. AX x cap direction. In y cap direction component is AY. So this is the component of vector A in xy plane, AX x cap, AY y cap. And in z direction, its component is AZ. Then vector A is given by this. This is the vector A. And this direction is A cap. Is it clear?
Yes.
You can resolve the vector in three components. This is the general vector A in space, but in your coordinate system, you can represent A vector in three components: AX x cap, AY y cap, AZ z cap. XY component, this is in XY plane, and AZ will be perpendicular to it. Yes or no? So that is the representation of a vector in Cartesian coordinate system. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now we talk about position vector. What is the position vector? Let's see the position vector. Position vector. So any point is represented by its own position vector. In vector notation, each point is represented by its position vector. So if a given point whose coordinate is x, y, z is represented by its position vector x x cap, y y cap plus z z. This is so x for different point x, y, z will be different. So let's see, this is x cap, this is y cap, and this is z cap. And we have a some point P whose coordinate is x, y, z. This is the origin. This is the origin O. So if you connect origin with point P, this is its position vector R. And in component form, you will see this will be x, this will be y, and this will be z. Yes or no? So for different point, if you change x, y, z, you will get another point. So this will be the position vector. If you another point, this will be the position vector. So this is the position vector, and its direction of position vector is given by r cap. R cap is in the increasing direction of r. Yes or no? Let's so I am representing, this is the point. So this point P coordinate is x, y, z. And let's see, unit vector is r cap. So magnitude of r is given by small r, this will be given by what? X square plus y square plus z square. R cap is given by vector r by mod r. This is the unit vector. Yes or no? So this represents the position vector of any point in a space. So for different xyz, you will get different position vector. Is it clear? What is the position vector?
Yes, sir.
Now, when you have to find line integral, surface integral, and volume integral, you will see we will talk about, in line integral, we will talk about dl vector. This is the infinitesimal displacement vector. When you have to find surface integral, we will talk about area element, dA. And when we will talk about volume integral, you will see d tau is volume element. So in different coordinate system, we have to see what is dl, what is dA, and what is d tau. Okay? Only then you will be able to calculate line integral, surface integral, and volume integral. So let us first see what is dl vector. We call it as infinitesimal displacement vector. Infinitesimal displacement vector. DL. DL is infinitesimal displacement vector. So what does this DL vector represent? Now see, if you are at point P whose coordinate is x, y, z. Now if you move to another point Q, by elemental change in x, y, z. So x changes by x plus dx, y changes by y plus dy, and z changes by z plus dz. And z changes by z plus dz. Then you will see position vector r changes to r plus dl. R to R plus dl. So this elemental change in position vector is called as infinitesimal displacement vector. Yes or no?
Yes.
And this changes along R cap only. Let's say this will be the point Q. So this elemental change along R cap is dl vector. Is it clear? This elemental change along R cap means you are at point P whose coordinate is x, y, z. So change x by dx, y by dy, z by dz. So what will be change along R cap? That change is called as dl vector, infinitesimal displacement vector. Okay? And this dl vector, how you will write dl vector? Can you say? Just tell me what will be dl vector? Dx x cap dy y cap plus dz z cap. Dx x cap, dy y cap, and dz z cap. Is it clear? You have to remember dl vector in Cartesian coordinate. Now you can visualize the dl vector. Let's see how we will visualize. Let's draw an elemental cube around point P. Let's call it as elemental cube. Elemental cube. Elemental cube whose sides are dx, dy, dz. So let's draw an elemental cube. This is an elemental cube. Now this point is P. P. This point is P, whose coordinate is x, y, z. So this coordinate is x, y, z. And this is x cap. This is y cap. And this is z cap. This coordinate is x, y, z. So if x changes by dx, so this change will be dx. Y changes by dy. So this changes dy. And this changes dz. So you will move to point Q. So this will be point Q. Yes or no? Now this
Yes.
diagonal length, this diagonal represents the dl vector. Now you can easily visualize dl vector in component form. If you see this elemental cube, then if you connect P with Q with a dl vector, so dl has three components, dx x cap along x cap, you are resolving dl vector in component form along x cap dx, along y cap dy, along z cap dz. Is it clear?
Yes, sir. Yes, sir.
So in Cartesian symmetry, I have represented any vector A. We have defined the unit vector, what is the position vector, what is dl vector. In next lecture, I will also define area element and volume element. We will see dot product and cross product of unit vector. And then we will move on to the another symmetry, that is spherical polar symmetry. So that is the most important, because if you can visualize the spherical symmetry, you can easily visualize Cartesian and cylindrical. So that's why next lecture is very important. Don't miss the next lecture. Next two lecture, I will say spherical symmetry and cylindrical symmetry. Is it clear?
Yes, sir.
Yes, sir.
So any doubt up to this point?
No, sir. No, sir.
Okay. So then we will meet you tomorrow on same time, and don't miss the lecture. Clear?
Yes, sir.
Okay.
Yes, sir.
Thank you,
Meet you tomorrow. Thank you. Thank you, everyone.
Thank you, sir.
Thank you.